All right, as promised, here's a short video for Math 1314 to get us started in Chapter 3. Go ahead and see what I do here. I'm going to do a few problems that are mixed together, and that should explain everything that you see in the homework or on the assignment sheet. Okay? To get started, the topic is about quadratic functions, and that's just, I guess you could say, it's just vocabulary. What's more important for us is what's it going to look like. Well, that right there, that's a quadratic function. How are you going to read that? A number times x squared plus another number times x plus another number. All right? Looks just like that. Okay, so that's how we recognize the equation. For us, it'll be important to talk about the shape of the graph. And it's either going to look like this or like that. Both of those shapes are called a parabola. All right, and what's unique about that kind of shape is there's either a lowest point on it, like that one right there. If it opens up, it's got a lowest point. If it opens down, it's got a highest point. And either way, that goes by the same name. We call it the vertex. Okay, so how do you tell if it opens up or opens down? Well, it's all based on that number that multiplies the x squared. If it's positive, the curve opens up just like that. And if it's negative, it opens down. All right, there's the only two possibilities. Okay, so since the vertex is going to be an important point, I'll tell you something about how to find it. All right, the vertex is a point, and every point has an x and a y coordinate, and that's how you find both of them. Take the opposite of b over 2 times a, and that's the x coordinate. All right, well, how do you think you find the y coordinate? You take that number that you got for x and you put it in there, and that's always how you get y. So that's all this says. You can translate that as just plug in the x into the function and you get the y. And that's always how it happens. Okay, let's see an example. Say I got you warmed up and I told you this is what we're going to be doing, and then I take my first problem, and nobody would think that this looked exactly like that. It doesn't appear to be the same kind of thing. But if it is in the lesson, it's in the section, and I'm sure that if we work on it and do what's there, we can turn this into that, and then we'll have our framework to get answers. What does it ask us? It says, for this, what's the vertex, the x-intercept, the y-intercept, the axis of symmetry, and then after you get all that, draw the graph. Okay, some of this stuff we've talked about already, and some of it we haven't, but I'll discuss all of it here. All right, it's 22 from page 343 in the book. So the vertex, well, I think I should get to the point where I've made this look like that formula I gave you. So here's my thought process. I can say, okay, so is this going to be like this? So I'll put question mark as if, can that be? Well, let's try to work on it. What can you do there? We could move the 3 to the other side, and that seems like a good start. So if we do that, then it looks like this. And are we there yet? No, we're not quite there yet. So we'll square this. And how would you do that? Well, to square anything means you multiply by itself. So that would look that way. And then what? To multiply that together that way, that's going to be x squared minus 2x plus 1. And then you still have this plus 3. And so now we're finally going to get to that. It's going to be x squared minus 2x plus 4. Okay. So let's look at this instead of that. I mean, they're, for the sake of doing math, they're the same thing, but all of our formulas that I've given you so far match this one, and so I got it to that point so we could work it. Okay, so the vertex. Take the negative of b over 2. Well, it's a, b, and c. So as I look at that, in this context right there, I would say that the A was 1, the B was -2, and the C was 4. Okay, so the vertex should be the negative of B. So what's B? Well, B is -2. So it's going to be the opposite of that over 2 times 1. Okay? And I get a number if I do that. And how do you find the y coordinate? Well, you have to figure out what that is first, and then you put it in, and that's how you get y. So I'll put question mark as if, hold on a second, I got to figure out this number before I can tell you that one. Well, so what's this? Opposite -2 is 2, over 2 is 1, so I get 1. And then say I put 1 into all that, I'll get 1 minus 2, which is -1, plus 4, which is 3. So 1, 3. Or the vertex is the point on the graph where x is 1 and y is 3. All right, so we got that. X-intercept. So the graph, if you take any graph, maybe it hits the x-axis somewhere. So how do we find the x-intercept? Well, on the x-axis, where the curve or graph hits the x-axis, one thing has got to be true about that, and that's that y is equal to 0. Isn't that true? Isn't it true that at every spot on the x-axis, the y-coordinate is 0? So that's how you find it, all right? So let's take remember we're using this equation, okay? Let's take that and do this, and whatever answer we get out of that is the x-intercept, okay? So I put 0 and then x squared minus 2x plus 4, okay? All right, and I have find some way to solve that. Have we ever seen anything like this? Yeah, we've talked about how you solve that before. You can use the quadratic formula. You can factor it. I guess it depends on what you want to do. I can't see how you would factor this one. Okay, so I'll solve it this way with the quadratic formula. So how does that work? What's the formula? Negative b plus or minus root b squared minus 4ac over all that. Okay, so I take the opposite of -2 plus or minus -2 squared. Well, that's going to be 4 minus 4 times 1 times 4. Okay, all right, so I get that all over 2a. What's that? Okay, so x equals 2 plus or minus root 4 minus 16, that's -12 over 2. Okay, I put 2a, well, a is 1, right? So just 2. Okay, well, what's that mean? Square root of -12, I don't have, as far as places on a graph, that doesn't get me an answer. Root -12 is not a real number. So, well, for me that means that there's no x-intercept. Okay, well, how could that be? Well, maybe the curve opens up and the x-axis is below it, and so it never hits it. Okay, that must be what this means. Now, okay, you could, I don't know, depending on how much you think about this, you could say, well, that second step, you didn't have to do that, because if that's the vertex, and if it opens up, how could it possibly hit the x-axis? Okay, so let's skip a little bit. Let's go down here to the graph, and I'll show you what I mean. So here's what we know about this so far. Imagine I have graph paper. All right, I got the x and the y, and the vertex is at 1 for x, 3 for y. Okay. So I got this scale here. 1, 1, 2. There it is. There's the vertex. Now, this curve is a parabola, and it opens up because that number right there in front of the square is positive. Okay. So there's the x-axis. here's the vertex. If it opens up, well, how could it ever hit the x-axis? If it's from that vertex, this shape, it's just not going to hit the x-axis. Okay, alright, so that's trying to solve it. That's what I figured out. But I guess if you think about the picture, you can still tell that there's no x-intercept. Okay, so the y-intercept. The y-intercept would be where it hits the y-axis. And I guess you just flip this around. On the y-axis, x has to be 0 everywhere. So we just jump into this and say, I can find you that point by doing this. Okay, so let's again, we'll use that. What's y if x is 0? So it would be 0 squared minus 2 times 0 plus 4, 0, 0, 4, so you just get 4. Okay. Alright, so the y-intercept is 4. It hits the y-axis at 4. Okay. To give the answer, we'll say the point where the curve hits the y-axis is there. Alright, now, I know I had these in order, like we're going to do this, and then this, and then this, but maybe we can piece together the graph. Okay. Alright, so 0, 4, so where's that? 1, 2, 3, it's right here. It's gonna do like that anyway, because that's the kind of shape it is. So I'm not surprised if that's the vertex, that a point about there is the y-intercept. Okay, so that's a good time to bring up axis of symmetry. Okay, now I didn't mention that when I told you what this was originally, but this shape, you know, despite my drawings being done by hand and not being perfect, it has symmetry right down the middle. And all we mean by that is the left and right halves are mirror images of each other. It doesn't matter if it opens up or opens down. Okay, that line right down the middle through the vertex is going to be the line of symmetry. Okay, it's a mirror image of itself on either side. So, well, there's the vertex. I mean, it's like if I could imagine there being a dashed line right through that, it would be a perfect mirror image of itself on either side. Where's that line? It goes to the vertex. Where's the vertex? 1 for x, 3 for y. That line goes through 1 on the x-axis. So the axis of symmetry is that. And you say, well, how is that a line or a number? Well, in this form, what that is a vertical line that goes through 1, just like you have it on the x-axis. Okay, all right. Now, so that's the axis of symmetry. It's going to go through the vertex. Now let's finish drawing this. I know that it's got this shape, and I guess I could try to draw that over those 2 points, but how about this? If it's symmetric, if it's a mirror image of itself across that line, then where would the mirror image of this point be on the other side? Well, you know, that point, you just count. It's left 1, up 1. So I guess the mirror image is right 1 and up 1. That's the only way it's going to have symmetry. Okay, so we find that point automatically. Let's label them. This point is 2 and 4. And this point is 0 and 4. And that point's the vertex, 1 and 3. And what is the shape otherwise? It's a parabola, which I drew originally for you already, but that's what this one looks like with these points. We did the math, we found that those points are on there, and now you have the graph. Okay, now let's take one that's like this but goes a little bit further. So I have 42 on 343. So we're given something that is just like the last one, meaning that however you look at it, it's a parabola of some kind. Okay. Questions are different though. It says, does the function have a maximum or a minimum value? And once you answer that, what is it? Where does it occur? And then what's the domain and range? So how can we just answer that by looking at it? Well, here's what I would notice. That's already in the form that I would like it to be. You know, I gave you this as your instructions, and, you know, obviously that's just like it. It's a number times x squared plus or minus a number times x plus or minus a number. Okay, so let's do this. Let's say it's a parabola, it's a quadratic function, but a is -2, b is -12, and c is 3. Okay? Alright, well, okay, is that enough information for you to decide if it has a maximum or a minimum? Well, if it opens up, it has to have a minimum. If it opens down, maximum. And what does that one do? Opens down if a is negative. If that multiplying number for the x squared is negative, it opens down. Well, that's what we have this time. Okay, so I can tell that, well, it opens down. And so in that case, it has a maximum. It doesn't have a minimum. Why not? Well, I mean, the curve goes down forever. There is no lowest point, but there is a highest point. Okay. All right. Now, so say we answered that. What is the maximum or minimum value? Where does it occur? Well, it happens at the vertex. Okay. So what we're saying is our curve, as I mentioned up there, it opens down. It's like that. And this maximum point right here, that's the maximum value. There is no y coordinate bigger than what that one is. It will be found at the vertex. Okay? And what's the vertex? Well, there's a standard formula for that. What was it? It was the opposite of b over 2a. What's that going to look like this time? The opposite of -12 over 2 times -2. There's negative b over 2a. What about that other number? The y coordinate. What's that? Well, I don't know yet. Once I figure that out, I'll tell you, but I don't have it yet. So here goes. I get 12 over -4. What's 12 over -4? -3. Okay? All right. Okay, now to find the y coordinate, I need to take that x and put it in here and get the y. So let's do like this. We're going to do f of -3, -2 times -3 squared, minus 12 times -3 plus 3. Okay, that's me taking this x and trying to find the y. That's what it's going to look like. And I get, let's see, -3 squared is 9. I'll get -18 plus 36 plus 3. That right there is positive 18 plus 3, so that's 21. Okay, so that's 21. So the vertex, -3, 21. It's left 3, up 21 on the graph. Okay, now, all right, that will give us the answer. Now how are we going to report the answer? We'll say this, the max value, like which of these numbers is the maximum? It's the y coordinate. I'm saying there's no point further up on the graph than that one. 21 is as big as it's going to get. So we'll say the maximum value is y is equal to 21. And where does it occur? At the spot where x is -3. Okay. Now that's just, I don't know, it's just another way of describing where and what the vertex is, but I drew it, I made my case, that's what it is. Okay? Alright, now, so what's the domain and range? Let's try to think of it like this. For this, I'll draw as if this thing was actually on graph paper. Okay? So, on graph paper, we got the x and the y-axis. We know the shape and we know the vertex. Okay? So, imagine that we have where's that point? Left 3, up 21. So I don't know, like that basically. If we say that's 3 and that's 21. So like here's 3 negative on the x-axis, and like there's 21 on the y. Okay, so something like that. And from here we get a curve that is a parabola that opens down. Okay, so imagine down, it goes forever, right? You know, how much of it do you want me to draw? Yeah, just forever, very gradually getting a little wider and further down. You get the idea. Okay, well, the domain are of all the points on that, what the x can be, and the range of all the points on that, what the y can be. Okay, so when I look at it, I could say, well, the x can be anything. I mean, is there a point on that graph somewhere where the x is, I don't know, whatever, 5 or something? Yeah, it's going to gradually gets wider and wider and wider. Its span in the horizontal direction is infinite. That thing, if you keep drawing it, gets wider and wider and wider. It will cover the entire x-axis. Okay, so I look at it, and I can say, well, basically, the x can be anything. Anything between negative infinity and any number. There is no number on the x-axis that doesn't somehow match up to a point on the curve. And the y, what about the y? Well, it looks like that point being the maximum, y will be as big as 21, and that's it. No higher. Can the y be 20? Can it be 19, 18? Could it be negative? Yeah, because it goes down forever. Okay? So, all right, we'll say that y just has to be less than or equal to 21. Okay? All right, now that gets the point across what the domain and range are. What's interval notation? Let's do like this. Here's the proper way to give our answer. The domain is the interval from negative infinity to infinity, which means that x can be anything. In the range has to be negative infinity to 21. We got to include the 21, hence the bracket. What's that mean? It says, well, y can be 21 or 20 and a half or 19 or anything less than that. But 21 is the most that y could ever achieve on that. Okay, so there's the domain and range. All right, now really, we answered every part of this one just by knowing the shape to be what it is. That's it. Okay, let's take one more. And this would be question 58 from the book. Page 344, section 3.1. And for this problem, I guess we can say this is why we think about parabolas at all, okay? They do explain the motion of an object that's launched or thrown forward, okay? All right, and you could see that. Imagine that you take a ball and you throw it forward, just kind of throw it up into the air and forward. So it's like you're here, you release it, throw it forward, it might rise up a little bit and then fall back down to the ground, and it hits the ground at some point. Well, that's like this. It has that shape to it. This is the equation that describes where it is along its path, okay? All right. So here we have that scenario that a ball is tossed forward and rises up and falls down to the ground, and that's the equation that governs how it moves, okay? If you were to impose a graph on the path of this thrown object, that would be the equation to describe it. Okay, all right. How do we know it's like that? Well, remember this number, that negative in front of the square? That says it's a parabola and it opens down. Okay, which is what a ball would look like if it was thrown forward like that. It would rise up and hit the ground. Okay, so we're looking at a parabola that opens down right there. Okay, first question. What's the maximum height that it will achieve before it begins to fall back down to the ground? And how far from the point of release does that occur? Well, to me, that it sounds like it's just asking for the vertex. If it has this path, the vertex, as mentioned already, that's the highest point on it. Okay? So, how about, let's do this. Let's make a little sketch of how I think this is going to be. All right, we'll fill in the details as we work the problem, but I take it that if this is going to explain the motion of this ball that's thrown forward, then we get something like this. It's released here, you know, released from your hand, thrown forward and up. It rises up to some maximum value, some maximum height above the ground, and that's going to be the vertex. And then it hits the ground. Okay, some distance in front of you. Okay, so that maximum height, well, that's whatever this point is, the vertex. Okay, so let's just find the vertex, and we can accept that it's the answer to the first question. So the vertex, different question, same formula. It's negative b, so b is that number, over 2a. So in other words, we get that. What's the y coordinate? I don't know yet. We'll figure it out. Okay, that number, well, I don't know. So let's do negative 2.1 divide by 0.08. Okay, I didn't put the negatives in because two negatives divide into a positive anyway. So do like that, and it's 26.25. Okay, so this 26.25. And then what's the y coordinate? Well, what you have to do is take the x, put into that, and you'll get the y that way. So equation, I got 26.25. That's the x. That's what I'm going to put in. So negative 0.04 times 26.25 squared plus 2.1 times 26.25 plus 6.1. So I get 33.6625. Okay. All right. Now, which of these is the answer to the question? How? It says, what's the maximum height? Well, you know, there's the vertex. I'm saying that's the coordinate. That's the y coordinate. That's the maximum height. Okay? This is how far in front of you it is when it reaches the maximum height. Okay, so let's give the answer this way. The max height for an object thrown forward, moving according to that equation, the maximum height is going to be 33.6625 feet. It says all distances are in feet. Okay. How far from the point of release does it occur? Well, 26.25 feet in front of you. The x coordinate at that point is forward 26.25 feet. Okay. All right, so we'll just say maximum height's there at 26.25 feet forward or something like that. And then there's both answers to these questions. Okay. All right. Next question, where does it land? Well, visually, if that's the graph, it's going to land right there. Okay, that's what happens. How would you find that point? Have we tried to find something like that already? What would you call that point? I mean, I'm looking at it, and I'm imagining that that's the path of this object. But I guess as far as the math goes, that's the x-intercept. Okay, so let's translate this. I mean, most of the time in math, to figure out what we do, we do some translating of the question. So where does it land? I'll just think of that as the x-intercept. What else could it be? All right. And how do you find the x-intercept? To find the x-intercept, let y be 0. And then what's that look like if you let the y be 0? Well, it looks like this. 0, negative 0.04 x squared plus 2.1x plus 6.1. Okay, if you can solve that, you are finding where it lands. Okay, can you solve that? How do you solve it? Well, it's a quadratic equation. Ax squared plus bx plus c. There's a standard formula for solving that. So here goes. The answer to this is negative 2.1 plus or minus root 2.1 squared minus 4ac okay, can we agree? Yeah, over 2a. Alright, so out of this we should get the answer. Now, I don't know. Let's do this. Let's simplify this one step. Let me tell you what all that is. What's 2.1 squared minus, so two negatives, that actually makes a plus. I'll put plus 4 times 0.04 times 6.1. Okay? That's 5.386. So let's do this. We'll say negative 2.1 plus or minus root 5.386 over negative 0.08. That's how it works out. Now, when you do this, get the final answer with your calculator, there's a plus, and that gives you one answer, and then the minus gives you the other. There's only one spot, though, where it hits the ground. So only one of those numbers is actually going to be it. Now, when you do those, and you get a final answer out of it, one of them will be negative, and that'll be over there. Well, that's not part of our situation. And the other will be this one. It will be positive. So just keep the one that makes sense to be what you're looking for. Okay. The way I'll find that one out of this is I'll do negative 2.1 minus root 5.386. Okay. Divide by negative 0.08. All right. And that's going to do it. And that gives me 55.25, so on. Now, there should be instructions for the question about rounding, and maybe it will say like round to the nearest tenth, and that's going to be 55.3. Okay, so let's do this. Where does it land? It lands about 55.3 feet in front of you. Or we can say 55.3 feet forward. That's where it lands. Okay? All right. One last question. From what height was the ball released? Well, if anything is tossed forward like this, there is a point that you release it. And it's going to be that point. All right? Right there on the y-axis. All right, so how would you find that? This point on the y-axis where it releases and then moves up and forward and hits the ground. Well, that would just be the y-intercept. How do you find the y-intercept? Well, let's do this. First translation. From what height was the ball released? That just is asking us for the y-intercept. Okay, how do you find the y-intercept? You let x be 0. Okay, so say you do that up here. What's 0 squared? 0. What's 2.1 times 0? Still 0. 6.1 is what you get. The y-intercept is always going to be that constant. So we'll say, from what height was the ball released? 6.1 feet above the ground. So like you throw a baseball overhand, release it from 6.1 feet above the ground, and toss it forward and it falls down. That's the scenario that we have. Okay.